So how we've talked about moisture in the atmosphere and how that's important. We've talked about um, the things that are required for clouds to form. We talked about having a solid surface, and we talked about having saturated air. We talked about how it's important for it to be reaching its dew point in order for condensation to occur. So then we talked about the different processes that could cool our air. We talked about our convective lifting. We talked about our adiabatic temperature change, and we talked about our advective temperature changes. So now we're going to look at, once we've cooled down that air, now what has to happen next. So we've got this saturated air, it's cooled down, and we've got our condensation nuclei here that you can see in the picture, but it takes a lot for it to get big enough to actually be able to fall out of the cloud. It takes a lot more moisture in order for it to be heavy enough. So we got to look at how are we going to get the cloud droplet from being a condensation nuclei with just a few water droplets, a few water molecules attached to it, to something that's big enough like this to become a raindrop. So we're going to look at two different ways that our rain droplets basically get big enough to form precipitation. And our first one is warm cloud precipitation. This happens obviously where the air is warmer. It's called collision coalescence. So collision, where they crash, I call it the crash and stick. So collision, you crash, coalesce is to stick together. So basically, you have your water molecules that are up there in the cloud, and they just start crashing into one another. And water has a really high surface tension and want to stick together. That's why if you drop a little water on a desk, it like pills up and it stays together as opposed to just like spreading out all over the place. You put enough water and yes, it will run, but if you put just a few drops of water on your desk, you'll see that they actually stick together. And if you touch them, then all the water will go with it. Okay, and that's why ducks can float on ponds and stuff, because water has really high surface tension. It wants to stay together. So when they crash into one another, they stick together because of the properties of water. So our first one is warm cloud. It's happening in areas where it's not really that, I mean, it's cold because you're still high up in the atmosphere, but it's not as cold as it would be like in the polar regions. And so our water molecules crash and stick. It's collision coalescence. Our second kind is what happens in cold weather, and this is called the Bergeron process. And in this one, our water gets really, really cool, really, really cold, but because it doesn't have a freezing nuclei, it doesn't have something for it to actually stick to, it can stay liquid even though it's below 32 degrees Fahrenheit or 0 degrees Celsius. So we've got really, really cold water that stays as a liquid, and then once that freezing nuclei gets introduced into it, now everything will start to attract to that, and as soon as it does, it freezes. Because the water is below 32 degrees, it just needed something to stick to in order for it to freeze. And so we have liquid water that's below 32 degrees, touches a freezing nuclei, and it freezes. And we start to get those more and more stuck together, and then we get snow or ice. So our water up here is really, really cold, like I said, below 32 degrees. It's just waiting for a freezing nuclei. Once it has a freezing nuclei and it starts to stick together, now everything else has a solid surface, right? Because it still needs that solid surface. So when that happens in clouds, up here at the very top, it looks fuzzy. Usually frozen when there could be snow or when the water is frozen up at the top, the cloud has a fuzzier appearance. When it's liquid water, it tends to have sharper lines and a sharper appearance. In the middle here, this is why we get hail. Okay, in our thunderstorms, because we've got the liquid water that the updraft brings it up, the air that's pulling it up to make the cloud really tall, it gets pulled up, it freezes, it becomes a chunk of ice, it comes back down, and it gets sucked back up again, and it adds another layer of water, that water freezes, it gets too heavy, it gets pushed back down, and it gets pulled back up again. And it keeps happening until it's too heavy, or until the air starts to all be coming down instead of going up, and it starts to collapse, and that's where we get hail from. We measure our precipitation using a rain gauge. Rain gauges come in lots of shapes and sizes. You can have them in your backyard. They've got them at the hardware store. You can just stick them in. It's basically a cup with markings on it. It's only good for a localized area. So when we say that the average precipitation in Phoenix is such and such, what they really mean is the average precipitation at the airport where the rain gauge is. It's not really good for talking about widespread areas. Here's a hailstone. So you can see here in the middle, see how it looks like layers coming around. So this one's like half frozen, like there's only half of half of it. If you imagine the candy a gobstopper, you know how it has different colors and different layers. That's kind of what a hailstone does.